Namaste, welcome you all. Today let's continue the concept of electricity, and today's class we will discuss about the concept of the electrical energy and electric power. Before that concept, observe this circuit diagram properly. This circuit diagram is included of battery, plug key and bulb. And when you close the plug key, the current will start flowing from positive to the negative terminal of the battery. At that situation, what is going to happen is certain amount of work is done. That means the electrons start flowing here. This is the work done. Okay. Now let's go for our actual definition, that is called as the electrical energy. The total work done in maintaining an electric current in the electrical circuit for a given time. That means the total work done, the electrons start flowing, that is the work done. In maintaining electric current, this is the maintenance of the electrical current in electric circuit for a given time. From this point to this point, when the charge is coming or when the electron is flowing, certain amount of time is required. That's why simply we can say it as the total work done in maintaining the electrical current for a given amount of time. That simple concept is called as the electrical energy. And to explain this content, there is one formula here. W is equal to V into I into T. You already know that T is indicating the time taken, I is indicating the electrical current, and V is the electric potential, and W is indicating the electrical energy. Here E is not indicating electrical energy, E is generally used for electric field. That's why we will use the capital letter W. So W is equal to VIT. This is the formula of the electrical energy. And also you can write the same expression as, you already know about the Ohm's law, right? Ohm's law, you know that the current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided the temperature and other physical conditions remains constant. Okay, and you know the expression V is equal to IR. When you replace the V by the term IR, okay, W is same here, V is replaced by IR, I as it is and T as it is, then what will happen? I into I square, R as it is and T as it is. So electrical energy is having one more formula, that is W is equal to I square into RT, or you can also use the formula VIT. This is the standard formula of the electrical energy. And also remember, this electrical energy is having a SI unit as, or system of international unit as, Joule. Joule is the SI unit of the electrical energy. You know all the variety of type of energy, kinetic energy, potential energy, solar energy, electrical energy, all they are having same SI unit, and that SI unit is nothing but Joule only. And also remember, it is a scalar quantity, the quantity which has only magnitude, no specific direction. This is the explanation about the electrical energy. And one more concept, that is called as the electric power. Electric power is generally indicated by the letter P. And definition is, the rate of doing electric work is called as the electric power. The rate of doing electric work, the rate in the sense, time it will come in the denominator part. Okay, the rate of doing which work? Electric work. So you can also define it as the ratio of work done to the time taken. The ratio of work done to the time taken in an electrical circuit, that is also called as the electric power. Or simply you can say it as the rate of doing electric work, that is called as the electric power. And this is generally given by the formula P is equal to W divided by T. And you already know W is indicating electric energy, not work done. Electrical energy it is indicating, and T is indicating the time taken. Or you can also write the same formula as, you know already, W is equal to VIT, right? And the same value is substituted here, and T and T, okay, T is taken here, T and T both will get cancelled. What will remain is VI. P is equal to VI. That is also one more formula of the electrical power, where V is indicating the electric potential or potential difference, and I is indicating the electric current. You can use any formula. Some of the situation you can use this formula, P is equal to W by T, or P is equal to V into I. And generally we will use the SI unit for the measurement of electric power, that is watt. Watt is the SI unit of the electric power. When you go to the electric shop, you say give me 10 watt of bulb, give me 20 watt of bulb, give me 0.5 watts of bulb, not volt. Okay, watt, you will say watt. So that's why the SI unit of the electric power is watt. And remember, it is also a scalar quantity because it is not having any specific direction. This is considered as a scalar quantity. And you should remember some more points here. They are also asked in your main examination. 1 kilowatt is always indicating 10 raised to 3 watts or 1000 watts. 1 kilo, K term, it will, whenever the K term it will come, 10 raised to 3 you should remember. 1 kilowatt is equal to 1000 watts, or if there is a 1 kilojoule, you should say 1000 joule, okay? And 1 megawatt of power, 1 megawatt of electricity, 1 megawatt in the sense 10 raised to 6 watts, okay? And also remember 1 HP, horsepower, it is called as horsepower. 1 HP is equal to 746 watts. You generally we will use the term 1 HP motor, 2 HP motor, 1.5 HP motor, okay? So that HP is also used for the measurement of electric power, but 1 HP is equal to 746 watts. And also remember the commercial unit of measurement of electrical energy is kilowatt hour. The commercial unit of measurement of the electrical energy is kilowatt hour. This is asked in your main examination. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. This is the value of the 1 kilowatt hour, or it is generally called as 1 units, 2 units, like this type also. So this is the explanation about the electrical energy and electric power. In main examination they will ask you define electrical energy and write its SI in it and write its formula, like this type they may ask you, or define electric power and write its formula and SI in it, like this type also they may ask you. So read all this content properly and remember these formulas properly. They can be also asked in your numerical session also. When solving the problem, at that time also it will help you. So this is the explanation about the electrical energy and electric power. Thank you.